Today we're doing lesson 8.1 on function tables. Here's an example of a function table. We've seen something similar to it before when we've looked at ratio tables. However, with function tables, it's a little different. We have our input, we have our expression, and then we have our solution, which is called the output. We're going to get used to it. Our input is going to be x, we're going to have our expression, and our output is going to be our y value. So we're going to get that. Here's an example. A ruby anthropoid hummingbird beats its wings about 52 beats per second. What is it that we don't know, Rocco? Yeah, how many seconds? So I'm going to put a T for time. We do not know how many seconds we're trying to find. We don't know if we're trying to find 1 second, 10 seconds, a million seconds. So in this expression, we want to find the beats for 2 seconds. So let's write the expression for that as a group. What would the expression be that helps us find our answer? What would the expression be that helps us find our answer? And let's use it with our variable. Matthew, what would the expression be? Malia, what's your idea?
52T.
Yeah, 52T. Because we know it beats its wings 52 beats per second. So that's multiplication. 52 beats per second. Now, if we know there's 2 seconds, if we know our T equals 2, then what is our amount of total beats, Ben? 104. Excellent. So that's our class warm-up. We need to use variables in our expression. So now I want you to go to page 579, and you're going to do numbers 2 through 4, but do not move on. If I said 74, I meant 579. This first one should be easy. It's already provided it for you. So Carmen, what did you get as your expression when we filled it in?
I did
6
6 times 52.
times 52, exactly. And what did you find as your answer, Oleg? What did you find, Oswaldo? 312, yes. What about for the next one? First of all, what is our number of seconds for Mario? 20. So then what did you get as your expression?
S times
Perfect. We already have the S times 52, so we make it that 20 times 52. Excellent work. And Rocco, what's our answer? 1040. And then lastly, let's read this. A giant hummingbird beats its wings about 10 times per second. Make a table to show how many times a giant hummingbird beats its wings in 3 seconds. So normally we would have to come up with that equation, that expression technically. But we know its number of seconds is 3. We get 3 times 10. So everybody at the same time, how many times does it beat its wings in 3 seconds? 30. Excellent. So I want you guys to write this in your notebooks. I've crossed off the parts that you don't have to write. The reason that it's so much is because there's a lot of vocabulary words. I suggest that you write it out in bullet points per vocabulary word, per bullet point, okay? So a function is a relation that assigns exactly one output value to one input value. The output depends on the number of input. The function rule describes the relationship between each input and output. You can organize the input-output values and the function rule in the function table. In a function, the input value is also known as the independent variable, since it can be any number you choose. The value of the output depends upon the input value, so the output is known as the dependent variable. So since we can choose whatever we want for the input, it is the independent variable. That's how I remember it. Input, independent. And the output, what we get as our answer, depends on what we put in. Doesn't that make sense? What we get out is what we put in. It's kind of like the more work that you put into something, the better grade you get. So it depends on more what you get. Now, let's look at these. We have to get exactly one input for one output. What that means is that for each x value, there is only one y value. So what this is called is it's called the pencil rule. It's called the pencil rule. Now, if I'm putting my pencil up and down vertically, I should only have one x value for one y value. So is this first one a function? Yeah, it is a function. What about the second one? Is this one a function? Yes. Because I still only get one x value per my function. What about if I had something like that? No, because if I look at this, when I use my pencil, it's easier with the pencil, but I go down here and here. I have one x value, but I have two different y values because this is my y and this is my x. So here, I'd have one x value, but two different y values. So a function cannot look like that. A function must have one x per one y. That is what a function looks like. It follows that pencil rule. Now, here's the thing. The input and output of a function table can be represented as a set of ordered pairs or a relation. The x values represent the input and the y values represent the output. So I want you to copy down this bottom part. So what I wrote, the ordered pair, x comma y. I also want you to write it down as input comma output. And then I want you to copy down both of these t-charts because you might see it. You'll see a t-chart where it's an x and then a y, and you'll see a t-chart where it's an input comma output. So the way I can also remember that our x is our input and our y is our output is which letter comes first in the alphabet, x or y? Rocco? X comes first in the alphabet. And which letter comes first in the alphabet? I or O? I. So this one comes first and that one comes second. So that's how I remember it because we go from the first in the alphabet to the second in the alphabet. So here's an example. I got this and it says the output is 5 more than the input. So our equation, our expression is going to be the output is 5 more than, so it comes after the input, right? So that's our expression. For example, if I gave us 7 as our input, it would become 7 plus 5, which means our y is 12. So our rule for this, our function rule, would be that the output is 5 more than the input. So I want you to try this one. The warm-up. The output is 7 more than the input. First, what is our initial expression? At the bottom, I want our initial expression, the one with our variable. The one with our variable. Romario? Rocco? It's not times. X. What is it? Who knows?
Oh, plus.
What is it, Michelle? X plus 7. So x plus 7 is going to equal y. We know that it's more, which means plus. We know that's than, which means it comes after the input. So the output is, which means that's what it is, equals. The output equals 7 more than, so it comes after that x, the input. So that's how we figure this out. Our initial expression slash equation is this right here. X plus 7 equals y. X plus 7 equals y. So now you're going to fill it in with the proper numbers and you're going to tell me the output. Of course, this one's really easy. We just know how to add. But our numbers aren't always going to be so easy. Hannah wants me to explain how I got that equation. Here's how I got it. The output. Output means x. Is means equals. So that's why I have that equal sign. And you're wondering why I don't have x equals? It's because, yes, you're correct. Output is y. The output is. So output is, and I could also write it as output is 7 more than the input. So I've got input plus 7. So I'm just going straight through my word problem. You are correct, Ben, and thank you for noticing that. So that's how we do that. We literally just go about it as we're reading our word problem. The output is 7 more than the input. Especially because in the future, the way that we write it is it's going to be called y equals. We're going to get down to y equals, okay? So who would like to tell me the expression for the first one? Who would like to tell me? Romario. So exactly, Romario, you get 10 plus 7. We're used to having a variable in our expression, but all we've done now is just plugged in. And what is 10 plus 7, Anita? What's 10 plus 7? 17. So what is our next expression then, Oleg? Perfect, 12 plus 7. And Matthew, what does that equal to? 19. Lastly, Emerson, what is our last expression? 14 plus 7. And what is the answer to that, Alinza? Perfect, 21. Excellent. So, let's do this one. The output is 5 times the input. So what would our initial expression be? Our initial expression, the one with our variable. Rocco? Excellent. So we're going to do y equals x times 5. We could also write this as y equals 5x. So now I want you guys to solve. This one should be easy. Let's do these first together. It becomes 5 times 8, 10, or 5 times 10, and 5 times 12. So I'm going to call on sticks, and I'm going to see who is the lucky people that get an answer. Andrew, what is the answer to the first one? 40. Excellent. Jaden, what is the answer to the second one? 50. Excellent. And Anita, what is the answer to the last one? 60. Excellent. So, now we've got our reverse card here. So, sometimes you are given the output and you have to work backwards. This is an example like chapter 7, where we were given our output, but we had to work backwards. That's exactly what Rocco was saying, where I would be given something like 7 equals x plus 2, right? Instead of being given our input, instead of being given our x value, we would be given our y value. So that's like chapter 7. So let's look at this one. Here we have our output value, and we need to figure out our equation. We need to figure out our expression. So, if our y equals, we want it into a y equals something x. Y equals something operation x. Who can tell me what that expression would be? Anita?
Y equals 3x.
So, exactly. Y equals 3x. Great job. So the output is y is equals 3 times the input, which is x. Exactly. So, but now we know our output. So we have to plug it in for the other side. So for this first one, we get 6 equals 3x. And we need to show our work just like our last lesson. If it's 3 times x, how do we isolate x? If it's 3 times x, how do we isolate x? Elsie. Perfect, so we divide each side by 3. That 3 times goes away. And what is 6 divided by 3? Show me on your fingers. Yes! So in this case, we get our input is 2. Our next one, we get 15 equals 3x. And our last one, we get 21 equals 3x. So you still show your work. You're going to divide each side by 3, and you're going to find your answer. So, for our answers, Raphael, give me the answer to 15 is equal to 3x. Perfect, it's 5. He divided by 3 on each side, and 15 divided by 3 is 5. Next one, I want Melanie to give me the answer. What is the answer to 21 is equal to 3x? What is x? Perfect. We get 7. So sometimes we have to work backwards. So I want you to go to page 580 and 581 and do A, B, C, and D. So for this first one, it already gives us our expression. So we put this in. We get 4 minus 4. And what is our answer then, Oswaldo? What's our answer? 0. The next one, we get 7 minus 4. What is our answer then, Nathan?
3.
And then lastly, we get 10 minus 4. What is our answer, Rafi? 6. Excellent. We just plugged in for x. This next one, we have 3x. So what is our first answer? Lily. Perfect. So 3 times 0, we get 0. This next one, we've got 3 times 2. So then what is the answer then? Diana's absent. What is the answer then, Ben?
Wait, for which one? Exactly.
6. And then Rocco, what is the answer for this last one? 15. Excellent. Now, here we know the output but not the input, so we have to work backwards. Now, what we know is 1 is going to be equal to 2x minus 1. We know that 3 is going to be equal to 2x minus 1. And we know that 5 is going to be equal to 2x minus 1. So this is when we need to show our work. And remember, we do reverse PEMDAS. We do reverse PEMDAS. So, if we're doing reverse PEMDAS, what do we do first? PEMDAS. What is the first thing that we do, Hannah?
Wait, it's for
Reverse PEMDAS. Perfect. We do either the addition, subtraction. So, in this case, we're dealing with that subtraction. Let's get rid of that. How can I get rid of that? What is on the same side as that x that I have to get rid of? How do I get rid of it, Michelle? Perfect. I'm going to add 1. And I'm going to do it for all of them at the same time because I'm lazy. So, this side becomes 2. It's too light. It becomes, hold on, 2, 4, and 6. And that goes away. Now what do I have to do? Rocco?
Would you just do the 2x?
Yeah, I have to do something to that 2x. How do I show my work? What do I do to that 2x? Reverse PEMDAS, I have to solve. I have to get x by itself. The point is always to figure out what x and or y is. We got to get a variable by itself. So,
You add 1.
what is happening to this 2x? What operation is happening? Tobias? Multiplication. So I got to do the opposite of it. What's the opposite of multiplication, Gore? Division. So I'm going to divide each side by 2. So 2 divided by 2, all of those go away, and I'm left with x equals. This side, 2 divided by 2, I get 1. What is 4 divided by 2? Fingers up. 2. What is 6 divided by 2? Fingers up. 3. Excellent. So Miles asked how we did that. I had 1 equals 2x minus 1. I want to isolate that variable. I have the output, which is 1, and I want to isolate it. So I add 1 to each side so that that goes away. This becomes 2 equals 2x. It's multiplication, so I divide each side by 2. 2 divided by 2 goes away. 2 divided by 2 turns into 1. So I get x equals 1. This last one, we have our input-output. we get 17 equals 3x plus 2. 17 equals 20 equals 3x plus 2. And 29 equals 3x plus 2. So to help you with the first one, what we do first is we have to do reverse PEMDAS. So we subtract 2 from each side. That goes away, and the 17 becomes a 15. Then I'm left with that 3x. I want to get that x by itself, so I divide each side by 3. 3 divided by 3 becomes 1. It's gone. And then 15 divided by 3 becomes what? Show of fingers. 5. So I get my input is 5. So figure out the next two. Miles, what's the answer for the second one?
6.
It is 6 because we would plug that in minus 2. Minus 2, we get 18 on one side. Divide by 3. 18 divided by 3 is 6. Gloria, what's the answer for the bottom one? 9, because we would get minus 2. Minus 2, we get 27 divided by 3. I want you to go to page 582 and do E, 1, and 2. So for the first problem, Brianna bikes 12 miles per hour. The function rule that represents the situation is 12x, where x is the number of hours. Make a table to find out how many hours she has biked when she has gone 12, 36, and 48 miles. Then graph the function. So we have to figure out our hours, and we know x is hours. So what is going to be our 12, 36, and 48? Is that going to be our x or our y? Perfect. It's going to be our y. So we figure it out here. We've got 12, 36, and 48. We would have to see 12 equals 12x, 36 equals 12x, and 48 equals 12x. So the way that we would solve it is reverse PEMDAS, where we would divide. Divide each side by 12, we get x equals 1. We divide each side by 12, we get x equals 3. We divide each side by 12, we get x equals 4. So when we graph it, in 1 hour, she goes 12 miles. In 2 hours, or in 3 hours, she goes 36 miles. And in 4 hours, she goes 48 miles. For our other two, Isaiah is buying jelly beans in bulk. They cost $3 per pound, and a candy dish costs $2. The function rule, 3x plus 2, where x is the number of pounds, can be used to find the total cost of x pound of jelly beans and one dish. Now we need to find the total of buying 2, 3, or 4 pounds. If x is pounds, we fill it in here. 2, 3, or 4. Then we simply plug it in. We get 3 times 2 plus 2. 3 times 2 plus 2, 3 times 2 is 6, plus 2 is 8. Then we get 3 times 3 plus 2. 3 times 3 is 9, plus 2 is 11. The last one, we get 3 times 4 plus 2. 3 times 4 is 12, plus 2 is 14. Now, Jasper hikes 4 miles per hour. The function rule represents this situation is 4x, where x is the number of hours. Make a table to find out how much he has hiked when he has gone 8, 12, and 20 miles. Since it's not hours, it's going to be our y value. So now we have 8, 12, and 20. So for our expression, we get 8 equals 4x. We're going to get 12 equals 4x, and 20 equals 4x. To solve, we do division because it's multiplication. What we do to one side, we do to the other. So we divide each side by 4. 4 divided by 4 goes away. Divide each side by 4. 4 divided by 4 goes away. Divide each side by 4. 4 divided by 4 goes away. 12 divided by 4 leaves us with 3. 8 divided by 4, Sitlali, leaves us with 2. And 20 divided by 4, Titus, leaves us with
5. 40.
what is it, Sitlali? 5. Exactly. So that would be our answer. You have to pay attention to which is our x value and which is our y value. For homework, it's page 583, numbers 1 through 7.